In this video, we'll be learning about the exterior angles of triangles. Before we begin, please make sure you have either this sheet printed out or the digital copy open. Before we talk about solving or finding missing angles, we need to go over some key vocab. When we talk about exterior angle, an exterior angle is formed by one side of a triangle and the extension of an adjacent side of the triangle. So in the triangle below, angle 4 would be our exterior angle. You can also remember that exterior normally means outside. So it's the angle outside of the triangle. Remote interior angles are the two angles that are not next to or touching the exterior angle. So in the triangle above, we said that angle 4 was the exterior angle, which makes angle 1 and angle 2 the remote interior angles. Angle 3 is not a remote interior angle to angle 4 because it's next to it. We're going to come back to this third box in a second, but let's keep talking about exterior angles and remote interior angles. So taking a break from our notes, let's just keep talking about how to identify the types of angles. Interior angles, we just learned the past few days, and those are the ones inside the triangle. So on this particular triangle, this would be an interior angle, this would be an interior angle, and that would be an interior angle. Exterior angles are the angles outside of the triangle. So here, this would be an exterior angle, this would be the exterior angle, and this would be the exterior angle. Remote interior angles are the two inside angles not next to the exterior. So if this was my exterior angle, the two remote interiors would be here and here. So only excluding the one that's next to it, everything else. So these next few days we'll be looking at figures like the one on the right here. And so interior angles we know would be angle 1, angle 2, and angle 3. My only exterior angle I have here is angle 4. And the two remote interiors to that would be angle 1 and angle 2. And again, those are remotely interior to angle 4. Okay? So the key thing to remember is that remote interior angles are the ones that are not next to it, but kind of across on the other side of the triangle. So we're going to keep taking a break from our notes to specifically look at the relationship between exterior angles and interior angles. So first we have a diagram here of a triangle. It has 3 interior angles which are given to us, 50 degrees, 70 degrees, and 60 degrees. And then 3 exterior angles labeled. We can go ahead and use our knowledge about supplementary angles to figure out what each of those exterior angles are. Remember, supplementary angles form a straight line. So here I see that angle 1 and 50 degrees are supplementary because they form that straight line. So I know that together those equal 180 degrees. Well, that means that angle 1 would have to be 130 degrees. I can keep using that same logic to calculate the exterior angles of angle 2 and angle 3. So looking here at angle B, I know that angle 2 and 70 degrees have to equal 180, which makes angle 2 110 degrees. And then finally, 60 degrees and angle 3 would equal 180, so that tells me that angle 3 is 120 degrees. So now let's start to look at trying to piece together what does an exterior angle and the interior angles have in common. So to do that, we're specifically going to look at 2 interior angles at a time. So the first one says look at angle A, which would be here, and angle B, which would be here. Angle A is 50 degrees, angle B is 70 degrees. Together, that sum is 120 degrees. Then it says, where else do you see this angle measure? And we see it right here at angle 3. So let's break that down a little more and see what we have. I have an exterior angle of angle 3 right here. Then what we found is that these two interior angles together have a sum equal to this angle. Well, if we look at this relationship between this exterior angle and these two interior angles, we can see that these two would be the remote interior angles to this exterior angle. It's the two inside angles that are not next to this outside angle. So an exterior angle could be equal to the sum of its remote interior angles. Let's see if that's true for the other exterior angles. Next, if we look at angle B and angle C, B is 70 degrees, we used that last time, and C is 60 degrees. Together, those have a sum of 130. Well, I see 130 here at angle 1. And again, it's still true that this exterior angle is equal to the sum of its remote interior angles. And then finally, a final example here, angle A, 50 degrees, angle C, 60 degrees. Together, those have a sum of 110 degrees, which is here at angle 2. So again, this exterior angle, angle 2, is equal to the two remote interior angles added together. So in conclusion, and then we'll jump back to our notes to finalize this, any exterior angle is equal to the sum of its two remote interior angles. Let's jump back to our notes and keep working on this idea. So let's return to our notes to finish that last row in our table. What we just talked about and discovered was that any exterior angle is equal to the sum of its two remote interior angles. And we'll look at kind of what that looks like and how we can use that to solve for missing values. So the first type we could use this theorem for is finding missing angles. So if we look at this first example, I'm given two interior angles of 66 degrees and 50 degrees, and then an exterior angle of x. I can see that these two angles are the remote interior angles to angle x. So what that means is that x, the exterior angle, would be equal to the sum of its two remote interior angles. So here, x would be equal to 66 plus 50. So x would have to be 116 degrees. We can also use this to find missing remote interior angles. So here would be the remote interiors of x and 54, and then the exterior angle would be 115. So what I know is that the exterior angle of 115 is equal to its two remote interior angles added together. So that tells me that that would be equal to 54 plus x. So it looks a little different than the last example, but we can still solve for x by subtracting 54 from each side. So doing 115 minus 54 gives me that 61 degrees would be the value of x. So in this first example, we were solving for the exterior angle right here. And in the second example, we were solving for what the remote interior angle would be. Both of them using this idea that the exterior is equal to the sum of its two remote interiors. Let's look at a little more challenging type of question. So let's go through two examples where we use the knowledge that an exterior angle is equal to the sum of its two remote interior angles by solving for x. So here in this first example, I see that the exterior angle is the expression 4x plus 10, and then the remote interior angles are given to me as 2x and 70 degrees. So what I know is that the sum of those two remote interior angles, so 2x plus 70, is equal to the value of the exterior angle of 4x plus 10. So then it's an equation that I solve for x. I see that I have x's on both sides, so I'm going to first move this 2x over to the other side. So that would give me 70 is equal to 2x plus 10. Subtracting 10 and then dividing by 2 tells me that x would have to be 30 degrees. Then I can use that 30 degrees to solve for the missing angles. Now here, these look a lot more complicated because they have 3 different letters, but that's to help you identify what angle it is. So follow the letters. If I'm looking back at my triangle, I'm going to start at E, go over to D, and back down to C. That tells me that EDC is that 2x angle. So 2 times 30 degrees would be 60. I'll keep color coding because you know I love that. DCE, I'm going to start at D, go down to C, and then over to E. So that would be this 70 degree angle, which is nice because the work is done for me. And then finally, C to E to R would be this angle here, which would be the exterior angle. So what I'm going to do for this one is do 4 times 30 and then plus 10. So that would tell me that it's 130 degrees. If you'd like, if you feel like you get the hang of this, you can try the next one by pausing this video and then seeing if you have it correct. If you want to keep listening to me walk you through these, that's fine too. So here I have an exterior angle of 3x plus 13, and then my remote interiors here of 39 degrees and 2x plus 1. Again, I know that my exterior angle is equal to the sum of its remote interiors. So here I would have 39 and then 2x plus 1. What I'm going to do first is actually combine like terms before I move anything over. So I would have 3x plus 13 is equal to 2x plus 40 from combining the 39 and the 1. So now I'm going to move my x's over all to one side. And then I'm going to subtract 13. So x here would be equal to 27 degrees. So I'm going to write my final answer of 27 here where x is, and then use that to find the missing angles. So following my letters here, I have K, J, L. So K to J to L would be this 39 degrees. So again, I'm not actually using the value of x here. Then I'm going to look for JLK. So starting at J, going over to L, and then to K would be this angle here. So what I need to do for that is do 2 times my answer of 27 and then plus 1. So that would be 55 degrees. And then finally, the last angle they asked me to find is AKL, which would be A to K to L, my exterior angle. So I would need to do 3 times 27 plus 13. And that would give me a final, oopsies, calculator problems, one moment, 94 degrees. So one thing to notice while you're solving for these angles especially is that these two added together should equal that exterior angle. So for this second example that we just worked through, 39 plus 55 should give me 94 degrees. That's one way that you can kind of check yourself. And if not, if they don't equal the same thing, go back and check through your work because that means you might have messed something up.